All right, page 27 in your package. We've got 2 more days on this chapter, so today and Monday. Tuesday, we'll be doing some review for your tests, which will be on Wednesday next week. And then that'll leave us basically after Christmas to review for the final exam. Remember, if your mark is 75 or higher, you're exempt from the final exam, don't have to write it. But if you have assignments not handed in, right now they're not affecting your mark, but after Christmas, there'll be a dead date, and after that, they'll go in as zeros and your mark will go down. So if you have missing work, make sure you get it done. If you missed or you need some of those assignments, you need to give me a list of what you need and I can get them together for you. Might not be a bad idea to do that before Christmas so that you have time over the holidays maybe to work on some of that stuff. So today and tomorrow or Monday, we're going to look at questions where you might have two triangles together. This first example says that Renee works as a bridge inspection assistant for an engineering firm in St. John's, Newfoundland. As part of her job, she needs to continuously practice making the measurements and calculations she uses when inspecting in-service bridges. One day, she uses a diagram of the Alex Fraser Bridge in Richmond, BC, to practice making measurements. If the deck of the bridge is cracked or unsafe, it may need to be replaced. What is the total length of the deck needed for Tower 1 to the nearest tenth of a meter? So, if we were to draw the triangle that represents Tower 1, it by itself would not be a right triangle. All right? That entire triangle that represents Tower 1 is not a right triangle by itself. But that triangle is made up of two smaller triangles, which are right triangles. One of those would be this one here that I'm showing in yellow. That's a right triangle. And then you'll also have a second right triangle to the right of the first. Those are two right triangles. Actually, Jet, before you write on that, I think you left yours here yesterday. Oh, I was looking. I was looking at my watch. It was on the floor. Okay, yeah, you can take that. So we need to work with these two right triangles. We'll find the length of the base of the first triangle, x, and then the second triangle, y, and then we'll add them together. And that'll give us the entire length of the deck for Tower 1. So let's look at the triangle on the left here. If we label the sides, the side across from right angle is the hypotenuse. We're going to use a 50-degree angle. The side across from that is the opposite. The third side is the adjacent side. So for this first triangle, we're going to use the opposite and the adjacent. We're trying to find x, which is the opposite side. We're given 154, which is the adjacent. And we've seen that SOHCAHTOA tells us that the tangent uses the opposite and the adjacent. So the tangent of our angle, which in this case is 50 degrees, because we're using that triangle on the left, is Opposite on top, adjacent on the bottom. TOA tells us that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. As we've been doing, we make both sides a fraction and then cross multiply. 1 times x will equal 154 times the tangent of 50 degrees. So make sure your calculator is in degree mode, and then we'll go 154 times the tangent of 50. And it's 183.53. And that would be in meters because the height is in meters. So there's the base of the triangle on the left. That's part of the deck from Tower 1. We'll have to find y now because that is the other part of the deck from Tower 1. So to use that, again, we'll label the sides of the triangle. We're going to use this 56.5 degree angle up here. The side across from that is the opposite. The hypotenuse is the side across from the right angle. And once again, the adjacent would be the 154. It's the adjacent side on both triangles. So in this case, to find out what y is, once again, it is the opposite and the adjacent. Y is the side opposite 56.5 degrees, and we're given the adjacent side, which is the 154. So once again, it's opposite and adjacent, and we must use the tan ratio, but now the angle is 56.5 degrees. And by definition, once again, tangent is opposite over adjacent, so it'll be y over 154. Make both sides a fraction, and again, cross multiply. 1 times y will equal 154 times the tangent of 56.5 degrees. Which we can get on our calculator. So the length of y, the second part of the deck, is 232.669 meters. And then to get the total length, we'll add those together. We'll add the 183.53 meters onto 232.669 meters. So back to the calculator, we've got the 232.669 there already. Whoops. Plus 183.53 gives us 416.2 meters. And it does say to the nearest tenth of the meter, so that's what I did. So again, 2 triangles were needed to use here, and then we had to add those 2 pieces together to get what we were asked to find. Number 2, determine the length of CD in the following diagram to the nearest tenth of a centimeter. So the problem here is that CD is not part of a right triangle. It's not one of the sides of a right triangle. Right? This is the triangle that involves CD. There is no 90-degree angle there. So we can't find CD directly using SOHCAHTOA. However, what I can do is I can look at two triangles that are right triangled. For example, I can find the length of BC. So let's let BC be x, because that is the base of a right triangle. And I can find BD, which I'll let equal y right now. That is the base of the large right triangle. If I find those two and I subtract x from y, I'll have CD left. Yep. Okay, so that's what we need to do. If we can find the length of y, which is the distance from B to D, that is the base of a right triangle, and we can find x, which is the distance from B to C, that is the base of a smaller right triangle, and then we subtract them. Okay, Paige, you with us? We'll subtract those two to get our answer, which is the length from C to D. So let's find x first, which is side BC of the small triangle. We start by labeling the sides of this triangle, though. The side across from the right angle is the hypotenuse. You're given the angle of 18 degrees. The side across from that is the opposite. The third side is the adjacent. I need to find the opposite. I need to find x. We're not given the hypotenuse, not asked to find it, not going to use it. We're going to use, once again, the opposite and the adjacent to find out what x is. And that would be the tan ratio. Only tangent uses opposite and adjacent. So the tangent of the angle, which is 18 degrees, equals the opposite, which we've labeled x, over the adjacent, which is 4.8. Again, the co-apart tells us this: opposite first, adjacent second. Opposite on top, adjacent on the bottom. Make both sides a fraction, and then we cross multiply. 1 times x will equal 4.8 times the tangent of 18 degrees. Right, so to our calculator we go. 4.8 times the tangent of 18 degrees. So x is approximately 1.6 centimeters. And maybe I'm actually going to put a few more decimals in there. 1.5596. Because I have to add this to, or not add it, subtract it from the answer I get for y. So I want to carry some extra decimals just so I make sure I get the right answer rounded to the nearest 10. Okay, so now, like I said, our next step is to find the length of y, which is the side across from this large angle, which is found by adding 18 and 20 together, 38 degrees. That is the measure of this entire angle up there. 18 plus 20 is 38. The hypotenuse of the large triangle, again, is the side across from the right angle, which we're not going to use. Y is the opposite side, and once again, 4.8 is the adjacent. Once again, I'm going to use opposite and adjacent to find out what the length of y is. The base of the large triangle, which once again is the tangent. But now the angle is not 18, it's 38. And again, the total part tells us that it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. We're good?
Yeah, sorry, I just thought we used 20, sorry, I wasn't thinking.
Make both sides a fraction, cross multiply. 1 times y equals 4.4 times the tan of 38 degrees. And so it's 3.44 if we round to 2 decimal places, centimeters. That's the length of y. And so like we said, now we have to subtract the value we got for x from what we got for y. CD in this case will be the difference between these two. 3.44 centimeters minus 1.5596 centimeters. So I'll subtract 1.5596. And if I round that to the nearest tenth, it'll be 1.9 centimeters. So there's our answer. Okay? Example 3 says that Derek installs wooden decks and porches. He's building a deck that leads from a raised door to a backyard. The door is 60 inches above the ground. There'll be 2 flights of stairs separated by a landing. Before beginning construction, Derek examines a blueprint of the deck. To be safe, the flights of stairs should be installed at angles of elevation from 22 to 25 degrees. What is the angle of elevation for flight A, and is it safe? So the angle of elevation must be between 22 and 45 degrees. And so if we want to find the angle of elevation here for flight A, again, we'd be looking at this triangle right here. Where the hypotenuse is 48, and the height would be the same height as this 24 that's written to the left. So that will also be 24 inches. We want to find the angle of elevation, which remember is measured upwards from the horizontal. So it's the angle in the bottom right-hand corner. If we label the sides of this triangle, the side across from the right angle is the hypotenuse. Theta, the angle we're looking for, the side across from that is the opposite, and the third side is the adjacent side. In this case here, we're going to use the opposite and the hypotenuse. Those are the two sides we're given. We're not given the adjacent, not asked to find it, not going to use it. In this case, we're trying to find the angle theta. So when we write our equation, we have to use the sine, because only sine uses opposite and hypotenuse. The sine of the angle theta, and again, the slope part tells it it's opposite first, hypotenuse second. Opposite on top, hypotenuse on the bottom. To find theta, we go second function sine, or sine to the negative 1 of 24 over 48. So second function sine of 24 over 48. And theta is 30 degrees exactly. Didn't have to round that. And that makes that one safe because it is between 22 and 45 degrees. It is between 22 and 45 degrees, so it is a safe angle. And now we have to do the same thing for flight B. So again, if I draw the triangle that I will use for flight B, once again, the hypotenuse is 48 inches. We want to find the angle of elevation. So let's label that one X. In this case, I'm not given the length of this side across from here, but I can find it. It'll be the difference between 60 and 24. So that side will be 60 minus 24, which is 36. 36 inches. Okay, so again, we've got the hypotenuse here. The side across from angle X would be the opposite. Third side is the adjacent, which once again, we're not going to use here. We're not given the adjacent, not asked to find it. We're asked to find the angle of elevation X. And so once again, we will use the opposite and the hypotenuse, which is the sine ratio. The sine of angle X, and the so part tells it, is opposite first, hypotenuse second. Opposite on top, hypotenuse on the bottom. So the sine of X will be 36 over 48. And then to find out what X is, again, we go second function sine. Sine to the negative 1 of 36 over 48. Second function sine of 36 over 48, which would be 49 degrees if we round it to the nearest degree. That makes it not safe because, again, in order to be safe, the angle must be between 22 and 45. This is too high. 49 is greater than 45. This is not a safe angle. So he has to make that angle smaller. And one way you could do that is by making the adjacent side longer. That would make that angle smaller. Probably what he would need to do. Can't really adjust the height of that triangle unless you make this landing higher. You could make this angle theta here a little bit bigger because right now it's at 30 degrees, so we've got some room to play with there. You could make this angle greater, which would make this landing higher, which would make X a smaller angle. So you have to do some changes to the blueprint in order to make both of them safe. Example 4, determine the measure of angle PQR. So that's the angle you get by going from P to Q to R. We are trying to find this angle up here, theta. That's what we're trying to find. Okay, that's what we're trying to find. And the only thing we're given is this side, which is 9.8, which is opposite angle theta. But this side here is not part of the triangle that makes up angle Q, angle theta. So we need to do some work here in order to be able to find out what theta is. And here's what I will do. I will find out what this angle down here is. Let's call that X. I have the angle above it being 10, so once I find X, I can add it to 10, and that'll give me an angle of this large triangle. I already have one angle of it, angle S, which is a common angle to both triangles. Once I find X and add it to 10, I'll have this entire angle. Then we can find out what angle theta is. So, find angle X. I'm going to use a small triangle, PRS. The side across from the right angle is the hypotenuse. The side across from angle X that I'm going to find is the opposite. The third side is the adjacent side. We're going to use the opposite and the adjacent here. We're not given the hypotenuse. We don't need it. We need to find the angle X. And so we'll use the tan ratio here because only tangent uses opposite and adjacent. The tangent of X will equal, and again the TOA part tells it, it's opposite first, adjacent second. Opposite on top, adjacent on the bottom. To find X, we'll go tan to the negative 1 of 3.4 over 9.8. So second function, tan of 3.4 over 9.8. Whoops, 3.4. So that is approximately 19 degrees. So if X is 19, then this entire angle here will be the sum of 19 and 10, which is 29 degrees. And now I can find angle theta. Remember, all three angles of a triangle always add up to 180. If angle S is 90, that means the other two angles must add up to 90 as well. Theta and 29 have to add up to 90. So I can find theta by going 90 minus 29, which is 61 degrees. So there's the missing angle theta. All right. Example 5. Tag lines are essential safety equipment for using cranes. They are attached to the load of a crane to help steady the load and reduce the amount it swings. A crew of crane operators is moving a large piece of concrete sewer piping. Jeffrey and Frank each hold a tag line attached to the piece of piping. So you can see how long those tag lines are. You can also see the angle of elevation from Frank up to the concrete piping is 62 degrees. So again, Frank holds an 18-meter tag line at an angle of elevation of 62. Approximately how high is a piece of piping from the ground? So we want to find out what H is using that triangle on the right, which we can do because we've got the hypotenuse, the side across from the right angle. We're going to use the 62-degree angle. That makes this side the opposite. Third side is the adjacent side. So the sine ratio is what we need for opposite and hypotenuse. SOHCAHTOA tells us that. The sine of 62 degrees equals the opposite, which is h, over the hypotenuse, which is 18. So tells us that it's opposite first, hypotenuse second. Opposite on top, hypotenuse on the bottom. Thank you. So now when we cross multiply, 1 times h will equal 18 times sine of 62 degrees. So 18 times sine of 62. So approximately 15.9 meters. 15.9. Then it says Jeffrey's tagline is 21 meters long. What is the approximate angle of elevation to the nearest degree? So now we want to find out what theta is, the angle of elevation. And because I found h to be 15.9, I can use that. The hypotenuse is 21. Once again, the opposite side. That's the side opposite the angle we're looking for. We now know that's 15.9. Once again, I need to use the sine ratio here to find out what angle theta is, because I'm using opposite and hypotenuse. And the so part tells us that the sine ratio uses opposite and hypotenuse, and the sine of theta will be 15.9 over 21. So theta will be found by going sine to the negative 1 of that decimal, which I have in my calculator. So I'm going to use the entire decimal. It's always best to use the entire decimal if you can. It affects accuracy. Second function sine of the previous answer divided by 21. So to the nearest degree, theta is 49 degrees. There's the angle of elevation of Jeffrey's tagline. Okay, so we'll stop there. Like I said, we'll spend one more day, Monday, doing some more examples with multiple triangles. And then Tuesday will be a day for review, so that Wednesday you can write your test on trigonometry. Yes? Yep.